this equation here. So the first thing you want to do is you really just treat this like it's a quadratic, meaning like I'm gonna make this 3x squared equals 7x squared plus 4x plus 1. So x is really sine theta. We'll get back to that in a moment.
Just gonna turn into like a quadratic equation kind of thing.
Yeah, so I'm going to move this 3x squared over. So it's 4x squared, plus
Plus 4x plus
plus
1.
4x plus 1. And this is a equal 0. And then you factor this and you get 2x plus 1 squared equals 0. I know I'm skipping some steps, but
Yeah.
that's okay. So then you square root both sides and you get 2x plus 1 equals 0. X equals minus 1/2. But you're not solving for x, you're solving for sine theta. So you put that back in. Where does sine theta equal minus 1/2? So in your unit circle, that's the y value. It's minus 1/2 there and there. So it's like 7 pi over 6.
Then you list the y values for the
No,
answers.
you're looking for the angles. So
Okay.
so it looks like that's the one. Let me just confirm that on the unit circle because I know this is for a grade. Yeah, so those values are confirmed there. You're looking for where the y value is minus 1/2 on the unit circle. So there's those two
That's
angles.
super. That is very clear. Thank you.
Great. But you got a really hard one here to start. I don't know if this is your first one, but this is, you certainly didn't get an easy one to start out with.
These are not exactly the easiest in the world, for me at least.
Yeah.
Sending another one.
Okay.
Should be pretty quick. Sent.
All right, snipping that in, and this one's a secant, or secant cosecant. Oh boy. Okay, so there's more to this one. You got to get everything on one side generally. So we're going to say 2 square root 3 secant theta cosine theta plus 3 secant theta equals 0.
Okay.
And then you're going to factor out a secant theta. So you have secant theta 2 square root 3 cosine theta plus 3 equals 0.
Okay.
So you set these two equations, set secant theta equal to 0, which has no solution.
Okay.
And if you're not sure why, remember secant is 1 over cosine, and there's no way to make this 0.
Oh, divided. Yeah.
Okay. The one on the right, you set 2 square root 3 cosine theta plus 3 equal to 0, and you get cosine theta equals minus 3 over 2 square root 3. And then you rationalize. Oh, this seems like it's not right. You rationalize this, multiplying top and bottom by square root of 3. So you get minus 3 square root 3 over 6. And you get, it is right, minus square root 3 over 2. So you're looking on the unit circle again, where does the x value, where's the x value? Minus square root 3 over 2, and it's here and here. It's 5 pi over 6 and 7 pi over 6 again. Now you can also
cosine, right?
Sorry?
So negative square root 3 over 2.
Yeah.
The first one, and then the second one should be, let's see, negative 3 squared over 2. Is that it? Just
That's
one?
it. There's two values. 5 pi over 6. Well, there's two places where this is true. Cosine theta equals minus square root 3 over 2. And you're finding those on the unit circle.
Okay.
Is it clear? Because we're going to do more of these, but they're all the same. You solve the equation, find where it is on the unit circle, and that's your answer.
Oh, that's it. Oh, okay, that's clear.
But I mean, they're not easier by any stretch, but they're what they are. By the way, what's the website that you're using for this? Is it
quizzes?
Okay.
Sometimes the answers are on the web. The other times you can't find them.
Right.
Just sent the next one.
All right, there it is. Got it.
Excellent.
Are you coming up on graduation?
We're getting to the home stretch. Yeah.
All right.
It's taking a long time though.
Well, all right. So this one is 4 plus 4 tangent theta. You want to factor out a 4, so you get 1 plus tangent theta equals 0. This doesn't have a theta in it, so you don't set it equal to 0. So you set this part equal to 0. 1 plus tangent theta equals 0. Tangent theta equals minus 1.
Wait, let me look at what -1 is on the unit circle. And that's just
Okay.
pi.
There's two places where that's going to occur. There's one here at 3 pi over 4, and then there's one if you go all the way around 7 pi over 4.
Wait, why is that again?
What do you mean? Why is that again?
For since tangent theta equals
Okay,
-1.
so that means it equals square root 2 over 2 over negative square root 2 over 2, or negative square root 2 over 2 over square root 2 over 2, which only occurs at these places on the unit circle.
Okay. I'm still not clear because I think because what I in my head when I see that -1, I look to the pi on the unit circle.
So there's a slight shortcut. So there's two places in the unit circle that have tangent of theta equal to 1, and they're here at the 45 degrees because this line has a slope of 1, which equals the tangent of 1.
Oh.
And that's at
Hmm.
45 or 40 pi over 4, and then 5 pi over 4. But if you go the other way, where tangent of theta equals -1, that's where the slope is equal to -1, and that's at 3 pi over 4 and 7 pi over 4. So
Oh.
you can almost remember those. Like, I mean, maybe it resonates to you at it, time it will, but you've got to create ways to remember this, if it's
So,
important to you.
so for tangents, it's at 45-degree angles, and that's how I'll remember that. Kind of make a pizza slice from the middle, make it into
Yes,
eighths. I guess that's
exactly.
the way I'm gonna make it.
Okay,
Remember it.
that
Um,
works.
is there gonna be like is there another type of thing that's kind of like this with tangent where it's at a different
No,
place on the unit circle? Like
no,
it?
these are the nice places for tangent. So that's all you got.
Okay. All right, I'm gonna send you that next one. All right, so the answer is at 3 pi over 4, the 7 pi over 4. Click on that. That is correct. All right. On to the next one.
Okay.
I'll send you a picture of this next one. Let's see. Where is it? Where is it? Where is it? Appreciate the help. You're making it very clear for me.
Of course, of course. I'm glad to hear you're almost graduating.
I am glad about that too.
Okay, it's come in here. All right, so this one's more straightforward. This would be like an earlier one that you would get before some of these other ones. So this one, I call it a direct solve. So you just solve for sine x in this equation. Sine x equals -4. If you solve that for
Oh yeah,
sine x,
because -1 and then times 4 and
and then you have to
-4.
remember that, yeah, and then you have to remember that sine is bounded between 1 and -1. So can sine x ever be -4?
Never. Still
Never.
undefined. Excuse me.
All right. Let me send that next one. Sent.
Have you made plans for beyond high school?
Yeah, I'm gonna go to Northwestern Prep over in Crestline, California, for a semester, and then I'll transfer to a civilian college for my second semester, and then decide whether or not I want to go to an academy or if I want to just go to a regular college.
All right. Well, you got a plan. That's great.
I'm happy with it.
All right. This one is kind of a direct solve as well. So sine squared x equals 3 over 4. But then you have to take a square root, and this is where sometimes if your algebra isn't solid, you don't know what to do here. So when you take the square root of both sides, it's plus or minus square root of 3 over 4. Okay, and you have to be able to reduce that, but there's two things there. You have to be able to reduce it, and you have to realize that that's plus or minus. Okay. So that's plus or minus square root of 3 over square root of 4, which is plus or minus square root of 3 over 2.
Bless you.
Thank you. Okay, so there's now, it's not just one value you're looking for on the encircle. You're looking for wherever it's square root 3 over 2 or negative square root 3 over 2.
Okay.
Okay, so like here's square root 3 over 2, here's square root of 3 over 2, so that's pi over 3, that's 4 pi over, no, 2 pi over 3, and then down here and down here. So you gotta get those values from the unit circle.
Why did these problems have like so many, like multiple of them to distract you?
Well, the like there's two, like since there's two places here and two places here, it's different values. So it's gonna be the one with 4 for sure, and then I just haven't having a little bit of a brain fuzz here where I can't get the right values. 4 pi over 3, and then 5 pi over 3 for that. So like the top two are for positive square root 3, and then the bottom two are for negative square root 3 over 2.
Oh, okay. That's understandable. On to the next one. Sent.
All right, waiting for it. All right, so this one is more complicated than the previous ones. It's kind of like the first one we did. You want to get the sine squareds on the left and the numbers on the right. So there's one sine square on the right, but 3 on the left. So that means 2 sine squared theta. And then you get 5 here, so you subtract 1 equals 0. Subtract 5 to get that.
Okay.
Set sine squared theta equal to 1/2. So sine theta equals plus or minus square root of 1/2, because there's two places here. So it's plus or minus square root of 1 over square root of 2, plus or minus 1 over square root of 2. And when you rationalize that, it's plus or minus square root 2 over 2.
Wait, how do you get that?
You multiply top and bottom by square root of 2.
Oh, all right.
That's what I meant by rationalize. That's why there's a lot here that there's a lot here to unpack. You know, a lot of things that are just assumed that you know.
It's like it's gonna have like 4 answers because I think it's gonna be like 3 pi
Yep.
over 4,
Yep.
pi over 4, then 7 pi over 4, and then
Yep.
5 pi over 4.
It's all the pi's over 4.
All right.
You got it.
All right. All right, on to the next one. I'm sending in. Guys, screenshot this next one. Now we're on to here. Clip this up. Send the next one.
I'm gonna say this, even though you may already know this, but I will be available if you need help in your future classes. A lot of times, sometimes students don't think that I help with college, or if I help with college, I don't help with high school. It's all the same. Just you're in a different spot, different math. It's the same math, just different place. So
I'll make sure to keep in touch.
yeah. Hope your sister's doing okay. I haven't gotten a lesson with her in a while, so
Yeah, I think she's doing okay right now.
that's good. That's good. All right, so this one here, you got cosines on both sides, but you got one on the left, so you subtract it to the right. So you're gonna have 2 cosine x on the right equals 2. And then so you divide by 2, and you get cosine x equals 1. And this is the one I think you were thinking of. It's like, where does cosine x equal 1? Only at one place in the unit circle, right there at 0.
It's just that simple.
That's it. And there's not much else to do.
Can you explain it one more time just so I get it?
Did you get comfortable up to this step right here?
Yes.
Okay. I mean, there's only one place in the unit circle where the x value
It's
is
0.
1.
Oh, it's 1. My bad.
1
0.
right there. It could be cosine x equals 0.
All right. I will send you this next screenshot right here. And on to this. This is 203, so 204. Sent.
All right, so this one, you want to solve it for cotangent theta. So you're going to you're going to add 2 to both sides. That's cotangent of theta equals -1. Cotangent and tangent share a lot of properties at certain places because they're just reciprocals of one another. So the reciprocal of -1 is -1. So this is there's several things you can do. You could say, okay, cotangent is cosine theta over sine theta equals -1.
True.
So you could cross multiply here, and you could get cosine theta equals minus sine theta. You could divide both sides by cosine theta. And then you
get
could
minus something, or what do you get?
1 equals minus tangent theta. You can move the negative over, and you get -1 equals tangent theta. And these are the same.
And so, we do like the cross or whatever makes it into a piece of slice.
Yeah, exactly. So this one's where it's going down. It's that one. It's got the slope of -1.
Oh, I see.
Which is what that is.
That makes sense. Okay, so then let me look for the values there on my unit circle. So it'll be 7 pi over 4 and 3 pi over 4.
Yes.
All right. Apply. Send.
Hey, there it is. So this one you're going to solve for secant theta. Snip that in. Okay, so you're gonna add 5 to both sides. So that gives you 3 equals 3 secant theta. And then you're gonna divide both sides by 3, so you get 1 equals secant theta. So secant theta is really 1 over cosine theta. And if you solve for cosine theta, you get, you can do a little bit of cross multiplying here, you get cosine theta equals 1. So usually it's easier to turn it into a sine or a cosine problem, because again, we're asking where on the unit circle is the x value equal to 1.
Hmm.
That's right there.
So same idea, I guess.
Yes.
Number 10.
Are we close to being through this, or is there 20 total questions?
It's just 10.
Okay.
We're close. We're like on the last one, I think. Home
Great,
stretch.
great. Because I want to make sure we get to that worksheet. Although I think it's the same thing. So, do a
Good
lot
practice.
of practice.
Always good to have.
Okay, so this one you're going to solve for cosine theta. So you're going to subtract 4 from both sides, or subtract 5 from both sides. So you get minus 4 equals minus 8 cosine theta. Divide both sides by minus 8, and you get 1/2 equals cosine theta. So again, it's like where on the unit circle is the cosine theta, the x value, equal to 1/2, and that's here and here. Pi over 3, I think that's 5 pi over 3. If you want to check that. The x value is 1/2.
Oh, okay. Can we go back to, I got one of them wrong. It was the 4 sine squared x equals 3. What was the answer to that one? I think I clicked on the answer too fast or something.
Do you know which, this one right here?
Pi 3/4. It's just like, there we go. That's the end of that.
Great. All right, I've got that worksheet up. Do we need to go through all of them? Do you want to go through some of them? What I couldn't tell you. We might be able to get through all of them. I really don't know.
We can just go through as many as we can. We got the answers right below us, so that's all fine.
Okay.
Alrighty. Thanks again for your time. I appreciate it.
Yeah. You're almost done with school. It's a big deal. Hope you're gonna celebrate and do some stuff for it.
Definitely. I'm very happy that I'm almost done.
Yeah. So this one is whenever you only see one trig function, you just solve for it. So this one's only got a tangent square. No, it's on a so the first thing to do would be to move the 2 tangent squared over. So you get 1 equals tangent squared theta.
Yeah. And then squares, square root. Is that what you do after that, or what do you do?
You take a square root of both sides. So tangent theta equals plus or minus 1. Is the square root of both sides, plus or
The
minus
square
1.
root of 1 is 1.
Yeah.
Okay. So which part of the unit circle is it going to be on?
So again, there's if it's just 1, it's where it's got a slope of
Slope
1.
of 1.
That has a
You're
line that's
going
a
up.
slope of 1.
Oh, okay.
And so it's there and then all the way there.
So it's pi over 4 and 5 pi over 4.
Yes, pi over 4 and 5 pi over 4.
Okay.
And then for negative ones going the other way, that's 3 pi over 4 and 7 pi over 4. Oh, and this time I guess we do have to make a list. So it's pi over 4, comma 3 pi over 4, comma 5 pi over 4, comma 7 pi over 4.
Why did we include the 5 pi and 7 pi over 4 again?
Well, I mean, you gotta get all of these.
You gotta list all of them?
Yeah.
Okay.
Because it hits the circle at 2 places.
Okay.
I should do these in a different order, but maybe they're okay.
That doesn't matter to me.
All right, so this one it only has one trig function in it, so you just solve for it. So you subtract 4, you divide by 4, so you have sine squared theta equals 1/4.
Oh, wait, before you continue, I think that she said just do the odds.
Oh, I missed that. I'm sorry.
That was actually my bad. I didn't give you the instructions.
All right. This one is like the first one in that it's only got one trig function, but it's on both sides. You gotta move this one over here. So you subtract 2 cosecant squared theta, subtract 2 cosecant squared theta. So you have cosecant squared theta equals 1. You take a square root of both sides, plus or minus. So you have cosecant theta equals plus or minus 1. What is cosecant theta? Well, it's 1 over sine theta equals plus or minus 1. The only way this is 1 is if sine theta equals 1 or if sine theta equals -1.
Okay.
So where on the unit circle, sine is the y value, where on the unit circle is it 1 and -1? Well, it's up here,
For y, so 1 and -1.
and then down here for those two. So pi over 2, comma 3 pi over 2.
That's the end of that, right?
That's it. Sometimes they have 1, sometimes they have 2. There's not really a good way to tell you like, oh, this is how many solutions they're going to have ahead of time. It kind of is, but all right.
All right,
So
on to number 5.
This one has 2 trig functions in it, which means we might have to get creative. Not sure yet. You generally move everything to one side. So we're gonna move this 2 cosine theta to the left side.
And 3 cosine, -3
Yes.
cosine theta.
Yes.
Okay. Are we gonna be doing like any factoring or something?
Yes, you're gonna factor exactly. You're gonna factor out cosine theta. So you have 2 square root 3 sine theta minus 3 equals 0.
Okay.
So you're going to set cosine theta equal to 0, and then 2 square root 3 sine theta minus 3 equal to 0. And the one on the right, you have to do a little bit more manipulation. You get sine theta equals 3 over 2 square root 3. Then you rationalize by multiplying the top and bottom by square root of 3. So you get 3 square root 3 over 6 square root 3 over 2. So you end up getting
on the unit circle.
Yeah, but you got to do both of them. So you got 2 of these to solve for. So where does cosine theta equal 0 on the unit circle? That's the x value.
Yeah, x and y. So 3 pi over 2 and pi over 2.
That's right. So it's pi over 2 and 3 pi over 2. Where does sine theta equal square root 3 over 2? So that's the y value on the unit circle. That's
Pi over 3
here.
and
2 pi over 3. Generally, these match these bottoms, so you don't have to. You'll start seeing these patterns the more you do them.
you know exactly where to look.
Yeah. So those are your 4 answers. You can put them in order if you want. It doesn't really matter. On the ASU and U of A math placement test, they'll ask some variation on one of these that we've done tonight. Like this is what I would just encourage you is like, this is why you want to do well in your math classes, because you really don't want to have to retake this stuff over and over again in college. But they always ask a question like this. Was that 5? That was 5, wasn't it? We're gonna do 7 next. Okay, so this one's got a lot going on. Actually, quite a lot going on. Wow. Okay, so if you add 3 cosecant theta to both sides? I'm sorry, 3 secant theta to both sides?
Yeah.
Do you see that it cancels out?
Yeah.
That's good. So you get square root 2 cotangent theta equals cotangent theta secant theta. And this is where you got to move stuff around. I guess we'll go left. It doesn't really matter, but maybe you have a preference when you start doing these on your own. So because they both have a cotangent theta in there, you're going to factor that out. So you have the square root of 2 minus secant theta equals 0. And that doesn't seem right, but okay. Let me just check here. I just feel like that I didn't catch something, but okay. So you're going to set cotangent theta equal to 0 and square root 2 minus secant theta equal to 0. So this is square root of 2 equals secant theta on the right. And secant theta is 1 over cosine theta. So you can cross multiply here. Square root 2 cosine theta equals 1 times 1, which is 1. And then cosine theta equals 1 divided by the square root of 2, because you clear that on both sides. Multiply by the square root of 2 over 2 to rationalize, and you get this. So you're solving the unit circle. Where is cosine theta square root of 2 over 2?
Yes.
Okay. And there's 2 places again where that happens. That's here and here. Pi over 4 and 7 pi over 4. Okay.
Yep.
And then cotangent theta, a little bit more difficult. It's cosine theta over sine theta. So the only place this is 0 is when cosine theta is equal to 0. That's how rational functions work. So on your unit circle, again, it's where's the x value equal to 0? Well, that's up here, pi over 2, and down here, which is 3 pi over 2.
Alrighty.
Up to 9, I guess.
Yeah.
All right, this one has sine in it, but it's got sine and then sine squared. So we're going to make a substitution, but you get everything on one side. A lot of times that's a strategy. You get everything on one side. So you're going to add sine squared to both sides. So you get 2 sine squared theta equals sine theta plus 1. You subtract and subtract, so you get 2 sine squared theta minus sine theta minus 1 equals 0. And this is where it just depends on how visual you are. Like some students need to see this as 2x squared minus x minus 1 equals 0 to factor. Some can just do it with the signs. I mean, it's the same thing, but it's just visually like which do you like or which are you more comfortable with? It doesn't matter. Like they're both right. It's just can you figure this out? Like, are you okay with doing this? This is plus 1 minus 1. This is 2x minus 1, x plus 1. So you can see they're exactly the same.
Yeah.
I'm sorry, I have this wrong. It's minus here, plus here.
Okay.
Yeah, didn't catch that. So on the left here, I mean, because if you do this over here, I'm sorry, you're saying x equals sine theta. You have to be sure that you back substitute it in. If you take calculus, you'll see that back substitution more in it. But on the right, on the left here, you're setting each of these equal to 0. 2 sine theta plus 1 equals 0. Sine theta minus 1 equals 0. And so on the left here, it's sine theta equals minus 1/2. Sine theta equals 1. So you got to find those values on the unit circle again. So the first one is the y value minus 1/2. So that's here and here. So that's whatever, it's like 7 pi over 6 and then 11 pi over 6. And then where does sine theta equal 1? Well, that's only up here at pi over 2. So this one only has 3 answers, and that's like a difference, because usually you're used to like, oh, well, maybe it's got to always have an even number of answers, and nope,
All
it
right.
doesn't. It doesn't.
That's interesting.
Yeah.
11 will be our last one.
Oh, great. So 11 is the first kind of what I would consider like really hard one, because you have to know an identity, because here you don't have the same trig function, and there's no way to make a sine into a cosine squared or cosine into a sine unless you know the double angle formulas. So how do I want it? I'm sorry, not the double angle formulas, the Pythagorean identities. So the very first Pythagorean identity that you're supposed to know is, do you remember? I'm snipping it in now.
Oh, this one. Okay.
So cosine squared theta, if you solve for it, it's 1 minus sine squared theta. So this cosine squared theta gets replaced with 1 minus sine squared theta equals 2 plus 2 sine theta. And then you get everything on one side, because now everything's in terms of sine. So I'm going to move this plus over here and subtract 1. So you get 0 equals 1 plus 2 sine theta plus sine squared theta. If I just reorder it, sine squared theta plus 2 sine theta plus 1 equals 0. Again, you kind of have your choice here. Do you see this? Are you okay with it on the left, or do you prefer this on the right? Because sometimes on the right, you're like, oh yeah, that's x plus 1 squared. Maybe you see that.
More clear.
Maybe it's more clear. It ends up being exactly the same on the left and the right. So on the left here, you have to set sine theta plus 1 equal to 0, because anything squared, the only thing squared that's 0 is 0. So where does sine theta equal minus 1? Well, that's on the unit circle again. Again, it's very repetitive here, down here at 3 pi over 2. That's your only single answer for this one.
Oh.
So it's possible to get like one answer. Well, actually it's possible to get no answers. One answer, 2, 3, 4, 5. You can just variations on all of these.
All right. I guess that's the end of that.
Okay, is that everything you'd like to work on today?
Yeah, I think this is everything I wanted to work on today. I appreciate your help.
All right, I'll send the notes and the screen recording out shortly. Thanks, Jack. Have a great night.
Thank you. You too.
Bye
Bye-bye.
now.